Hi Year 11, I'm going to show you how to do constructions this morning. Okay, so what we need is the basic equipment. We need a sharp pencil in a compass, we need a straight edge, often called in the exams, e.g. a ruler, and we need a protractor. Okay, so I'm going to go on to the first question. Now this first question basically deals with the basics of constructions. Okay, so the two basic bisectors. The first one is the angle bisector. So the very quick method to do this, okay, we just open up, we stick our points, it's the angle ABC, so we stick our points in the middle one, B, and we go do, 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 do. And the important thing is we don't move the compass at this point, we just go and stick our point at the two arcs that we just drew and draw across using two arcs in the middle. The next thing that we do is just go and grab our ruler, and we just go through from B through that arc that crosses, those two arcs that cross. Okay, perfect. Okay, easy. The next one, using a straight edge, again a ruler and compasses only, constructs the perpendicular bisector. This one's very quick. Okay, so you just go to either side of the line, so D first, open it to just over halfway, an arc above and an arc below the line. Do the same thing, again, don't move the compass in between, and like so. You see that? Okay, and then you just go and grab your ruler and you go through like that. Okay, right. Now in this particular set of questions from Save My Exams, they then go on to some more complicated questions. I'm going to actually skip to question 4 just because I think it follows on quite nicely from what we just did. So question 4, just find it, there it is. Okay, so just skip ahead to question 4 now, because this is another version of the perpendicular bisector question. Okay, it says complete part A and B using a straight edge. Again, there's the ruler, and compasses only. Show all your construction arcs. Construct the locus of points that are equidistant from the points X and Y. Okay, so you've got X and Y there, and you're going to put a line through those two. Oops, not the best line. What happened there? Got paper underneath. Let's try that one again. Okay, so there's the line there. Okay, and we're just going to do exactly the same thing. So it's just another version of the perpendicular bisector. Okay, you open it up, you do an arc above and an arc below, and you do the same thing on Y. An arc above and an arc below. Okay, and then you just grab your ruler. And those are all the points that are an equal distance away from X and Y. Okay, there we are. Perfect. All right. Okay, so can you imagine, like, if you measured, say, this point here, that is, whoops, let's do it in centimetres, that is 4.5 centimetres away from X approximately, same thing for Y. So each point on that line basically is equidistant, or the same distance away from X and Y. Okay, construct the locus of points that are equidistant from line AB, so it's this line here, and AC, which is this line here. Okay, so I'm going to actually bisect that angle there. Okay, let's look at that again. So AB and AC, so I'm going to bisect, this is the angle. Okay, I'm going to bisect the angle between those two lines, and that will be, therefore, the points that are the same distance away from those two lines. Okay, so same thing again, we just stick our point at A, we put an arc there and an arc there, and then we do the same thing inside. So stick, again, don't move your compass at this point, like that. Okay, you get your nice cross, and you will then stick your pencil there. Okay, there we are, lovely. Shade the region inside the triangle which is closer to AB than to AC. Well, this is the dividing line between AB and AC, so I guess all of this area here is therefore, this side of the line is closer to AB than to AC. Hope that makes sense. Okay, good. Right, I'm going to pick up where I left off then, when those pages that I missed out. Let's go back. So let's put them back in order. So we finished off at 1. Let's have a look at number 2. The diagram shows ABC. Using a straight edge again, and compasses only, where's that? Okay. Construct the bisector of angle ABC. So A to B to C, and this angle here, ABC. Okay. So again, okay, it's getting a bit repetitive now. It's the third time I've done it. We're going to do 2 arcs, and then we're going to do arcs that cross in the middle without moving the compass. And then we just go and put a line through, okay? Draw the locus of points inside the triangle that are 3 centimetres away from AC, okay? So AC is a line. Now this is a bit of a different question. We need to really think about all the places that would be 3 centimetres away from this line within the triangle, okay? So let's first of all think about the point A as a key point. So that's 3 centimetres away. And I guess over here, let's continue it. I guess the furthest away distance we could get within the triangle would be sort of, let's have a think. Would it be there, wouldn't it? Yeah. Okay. So that's sort of the dividing line, because everything else, you know, that's the furthest away we can possibly get if we were on that line. The rest of it, I mean, obviously this distance here is less than 3, isn't it? You can see how. So that's sort of the place that we would stop. So I hope that makes sense. All of those places there, yep, if you're just careful, are inside the triangle and 3 centimetres away from AC. Okay, good. Let's keep going. Question 3. The scale drawing shows a park A, B, C, D, E. So that's just saying where the vertices are. A, B, C, D, E. Okay, a pentagon, 5 sides. And the scale is 1 centimetre represents 20 metres. You can see that down here too, okay? And it says measure the bearing of B from A. Now this always causes problems, this wording. Measure the bearing of B from A. That means that you imagine that you are coming from A. There you are, okay? And a bearing has 2 things that you need to remember attached to it. We are going to face north and we're going to turn in a clockwise direction, okay? So imagine you're from A and you're looking to look at B, so measure the bearing of B from A. If I was stood at A facing north, what angle would I need to turn through from north clockwise to be facing B? So I'm just generally, that's just asking me to do is to measure this angle here. Let's call it theta, okay? So we're going to stick the centre of our protractor there, and it looks to me like that's about, is it a nice round number? Yes, it is. I think it's about 50 degrees. 50 degrees, okay? I'm going to write that there for my 1 mark, 50 degrees. Perfect, easy. Okay, now it gets a bit more technical. A straight cycle path crosses the park from E to BC. Okay, so E is the point, E's down here, and BC is this line here, okay? And it's saying constructs the cycle path if the path bisects angle AED. A very roundabout way of getting us to do an angle bisector, I hope you agree. Okay, so we're going to be going from E, open up, a couple of arcs. Okay, same thing we've been practicing 3 times already during this paper already. There's the, yep. And it's a cycle path that goes, we're told, from E to AC, and it bisects that angle. Okay, I think we've done those things then, haven't we there? So let's read it again. The straight cycle path crosses the park from E to BC. Okay, the path bisects angle AED. Yep, AED is being bisected, perfect. Work out the actual length in metres of the cycle path. Okay, so if I'm going to measure that very carefully using my straight edge, otherwise known as my ruler, it looks like it's 13.5 centimetres. Okay, now using this scale, 13.5 centimetres. What I have to do to get it into real life terms is to times it by 20 to get it into metres. Okay, so I just go and grab my calculator and I can find, I've just got my calculator on the side here, that 13.5 times by 20, let's write that down, 13.5 times by 20 equals, where's my calculator? There it is. Aha. Right, 13.5. 13.5 times 20 equals 270 metres. Okay, 270 metres. Next question. Alice cycles from E to BC on the path. Okay, so we're still talking about this path I just drew at a constant speed of 9 kilometres per hour. Show that 9 kilometres per hour is equivalent to 2.5 metres per second. So what I've got to do here, I've got to think about what 9 kilometres is in metres. Now 9 kilometres, how many kilometres in how many metres in a kilometre? Obviously There's 1,000, so 9,000 meters it is. And 1 hour, okay, so what we're starting with is 9 kilometers per hour. We've got to put that into meters and seconds. So an hour, how many seconds would that be? Well, there's 60 seconds in a minute, 60 minutes in an hour. So if I do 60 times 60, that would give me how many seconds there are in 1 hour, 3,600. Now, with a bit of luck, when I do 9,000 divided by 3,600, I'm going to get 2.5 as required. Okay, so there's my show that. So I arrive at that answer. That's the beauty of it. That's what we do with a show that question. Okay, find the time she takes to cycle from E to BC. Give your answer in seconds. Okay, now there's this lovely formula triangle we can use, which is speed is distance over time. And that tells us, going the other way, that time is distance divided by speed. Now I've worked out the distance, which was 270. Okay, that's the distance, the length of the cycle path, 270 meters. And I know the speed, I've just worked that out, which is 2.5. So if I actually do 270 divided by 2.5, I get 108. So it should take 108 seconds. Lovely. Okay, next one. A straight footpath equidistant from D and E crosses the park from DE to AB. Right, let's go and see what's going on here. So a straight footpath, let's look at the equidistant from D and E crosses the park from DE to AB. Right, DE is here and AB is here. Okay, and a straight footpath equidistant from D and E. So equidistant from 2 points. Aha, right, I think I'm looking to bisect this line DE then, aren't I? It's equidistant between D and E. Means that I'm going to find all the points that are halfway between. Okay, so I'm going to do my perpendicular bisector, which I have practiced previously in the previous questions. Yeah, okay, so I just grab that. Now what's it saying? Let's be very careful. Constructs a straight footpath equidistant from D and E, crosses the park from DE to AB, construct the footpath. So I'm within the park. Let's be very careful about this. I don't want to go outside of the park. Let's line it up. Okay. Oh, whoops. Try again. There we go. I could do with a sharper pencil really, but let's carry on. Whoops. No eraser handy. That's okay. I can live with it. It's okay. Right. Next one. D. Hopefully you'll be more careful. D, part 1, construct the locus of points that are 150 metres from A. Oh, you can't see the question. Construct the locus of points 150 metres from A and inside the park. Okay, so 150 metres. We were told earlier that 1 centimetre is 20 metres. So if I take my 150 metres and divide by 20, I can hopefully find how many centimetres I'm looking at. Yeah, okay, so my calculation there, 150 divided by 20 is 7.5 centimetres. Okay, great. Okay, so now I'm going to go to A. I'm going to open up my compass and I'm going to find all of the points that are 7.5 centimetres, really 150 metres away from A. All right, so much going on. Right, okay, A, there's my A. So, so hopefully you can foresee what's going to be happening here. I've got a section of a circle, a sector being drawn inside the park. Right, very important, it's inside the park. Now then, a region for activities, sports activities, is less than 150 metres from A, i.e. inside that circle I just drew, or semicircle sector that I just drew, and closer to E than to D, closer to E than to D. Well, I drew this line that divides E and D, so closer to E than to D will be to the left of this line, this perpendicular bisector that I drew. Okay, so within the circle and to the left of there would have to be this bit. I hope you agree. Okay, yep. Not including this part here, this segment. Okay, just this. Okay. Okay, lovely. All right. That was a long question. It's done. We've just earned ourselves 7, 8, 9, 10, 11, 12 marks, and the bearing 13 marks on that one. Lovely. Okay, let's move on. Okay, hopefully, we did number 4. Okay, already done. Perfect. Number 5. Oh, hang on. Oh, no, we haven't finished there. We've got part C on number 4. I didn't see that. Complete this part using a ruler and compasses only. Show your construction arcs. Construct the locus of points that are 4 centimetres from the line MN. Oh, this is a great question. Okay, this is what I call the racetrack method. Okay, so we've got a line now. A line is always 2 letters, okay, together. Like MN is the distance M to N, okay? And the line MN. And it's the locus of points 4 centimetres away. Right, so the first job, obviously, take my straight edge and to measure, to open up my compass to 4 centimetres, okay? And I need to take into account, first of all, the ends of this, right? If I was stood at N, imagine I was a dog tethered by a lead to the point N, and the lead was 4 metres, let's say, if we're working in metres, a metre is a centimetre. Where's all the places that I could go? I could only go to there. I mean, I could come around here as well, yeah? But I'm just going to do the semicircle, actually. And I'm going to do the same thing at M, okay? And then all the places, just that semicircle on this end, all the places I could go outside of the line, okay? Going away from the line, yeah? Okay. And the next thing I need to do then is just to fill in the rest. So it's a line. If I was 4 centimetres away from the line here, that's the furthest I could go. And if I was 4 centimetres away from the line here, as my maximum, that's the furthest I could go. I'm just going to now go and make sure that I am really thorough with this. I can only go from there. Okay, perpendicularly, I can only go 4 centimetres away. Here, 4 centimetres away. Okay, and here, let's make sure, 4 centimetres and 4 centimetres. Okay, and then I just sort of join up the ends and these points together. So we end up with that. Okay, there we are. Beautiful, look at that. Beautiful. And questions 5 and 6. And that's the end, actually. Right, that was quick. Using a ruler and compasses only, construct a triangle with 5 centimetres, 6 centimetre and 7 centimetre sides. The 5 centimetre side has been drawn for you. Right, easy peasy, this one. Sure you know what to do. All we need to do here is to take our ruler and open it up, first of all, to one of the other sides. We'll start with 6, we'll do it in order. We've got the 5 centimetre side already, so I'm just going to draw an arc, all the places that are 6 centimetres away from that side, okay, from that end there. Okay, so if we're going to draw a 6 centimetre side, all the possible places that I could, for that line to end, okay. Not all of them, of course, but I've just done a little arc, so I know that when I do this side here, I stick this end here, this is where I'm going to draw my 7 centimetre side. There'll be a place where the 6 centimetre side that could be drawn and the 7 centimetre side that could be drawn from those 2 ends of that 5 centimetre line could meet. There's only one place, actually, where we could make that perfect triangle as described. So there it is. There we are. Lovely. This is 6 centimetres. This is 7 centimetres. Always make sure that you label it and do not, under any circumstances, erase construction lines. That is the same throughout all of these questions. Never ever erase your construction lines. Final question. In this question, use a ruler and compass. Okay? Okay, perfect. Shade the region inside rectangle ABCD that is more than 2 centimetres from AD. Okay, AD again is a line. It's not A, which is just a point, or D, which is just a point. AD is a line. Okay, and more than 2 centimetres. Right, I'm just going to measure, actually. Maybe just a couple, I mean, minimum number of points that I need to mark out are 2 to draw a straight line, right? So if I just do those 2, yeah, that works. Yeah. What does it say? Shade inside rectangle that is more than, okay, so I'll come back to it because it's got this and, okay? It's got 2 descriptors here. Let's just deal with the second one and then we'll do some shading. More than 4 centimetres from B. Right, so let's measure 4, so let's open up my compass to 4 centimetres, stick my compass at B, and more than 4 centimetres from B. Okay, right, now let's reread the question. What does it want me to do? Shade the region inside rectangle ABCD that is more than 2 centimetres from AD and more than 4 centimetres from B. Ah, right, well it's pretty obvious to me, and hopefully you as well. I'm talking about that lovely ramp shape in the middle there. Okay, a lovely easy 3 marks. And that's it. And altogether there were apparently 33 marks, okay? These are always worth many marks in your exam, so worth getting your head around once you've practiced it a few times, and hopefully by this point today, you've got the hang of it. Okay, good luck. Well done.